My name is Will Rosenfeld, and I'm joined by Vivian Neely. So our talk is Garbage In, Good Out, Prompting LLMs with Multimodal Longitudinal Patient Records. Okay, so just to introduce myself really quickly, Will Rosenfeld. I am a healthcare data and AI specialist within our Google Cloud practice.
Hey all, Vivian, girl on FHIR and healthcare product manager at Google.
Yep. All right, so our talk today is intended to be fairly thought-provoking. We've had a lot of in-depth discussions about what the FHIR standard can do. I think that we're all fairly knowledgeable in that space. We're going to be focused today on sort of the frontier of what may be possible in the future and what is becoming possible now. So we structured it kind of like an abstract: background, methods, findings, conclusion. And we're going to lead off with a TLDR slide so that everyone can kind of see right off the bat what we're going to get to here. So firstly, we have a new large language model, Gemini 1.5, that can ingest massive amounts of data within the context window of the large language model at near perfect recall. That doesn't mean that it produces near perfect results. We'll get into that later. But in short, what can you do with it? Well, you can prompt this large language model essentially with an entire multimodal medical record that has full longitudinality, observability, whatever data that you have, and essentially whatever format that you have that data in. And you can pass that in along with your question in natural language. And the infrastructure for this is essentially zero, right? You're just passing it into a large language model, so no pipelines, anything like that. The results are generally pretty good, but there is plenty of hallucination risk. In fact, more hallucination risk than retrieval augmented generation approaches, and of course, more hallucination risk than deterministic approaches that are the usual FHIR approaches that you would use, like FHIR search or SQL on FHIR, et cetera. There is also decent latency and cost per query. So I think these are factors that will come down over time, but the underlying dynamic will probably remain. And then lastly, okay, well, what can you do with this? I think today it's best suited for what we call professional in the loop. We don't just want to say human in the loop because we don't necessarily think that it should be going straight into the hands of patients, although that's obviously their choice if they want to use the product for that. And it should probably be for proof of concepts today, as opposed to more expansive pilots or going into production. And this approach may have implications for the future of FHIR and when to use FHIR versus when to use FHIR as well as other data. So here's kind of a visual of essentially all sorts of data coming in, passing that straight into the context window of a large language model, and then taking that response and feeding it back to some sort of professional in the loop. And so we end up going from the traditional garbage in, garbage out. I think the easiest way to say it is it's probably like raw in, reasonable out. Garbage is probably not the right term because it's actually raw data, or maybe not raw, but whatever data you can get your hands on that you didn't have to pre-process. Okay, so now that I did the TLDR, I'll go into a little bit more detail. So first, I just want to say that Google is very invested in FHIR. This is a bunch of DevDays talks that we have this year. We believe that deterministic approaches are the right approach for the vast majority of use cases, particularly system-to-system use cases, for exchange of data, et cetera. But we do see generative approaches as being complementary to deterministic approaches as we move forward. Okay, problem statement. So longitudinal data, healthcare data is both longitudinal and comprehensive at its core. That's what it should be. But often what we end up with is data that's in the format that our systems can process, and that data doesn't necessarily make it into deterministic systems that exist today. It's multimodal, it's heterogeneous, et cetera. That's the data side. There's also the questions that you want to ask of your data. And that can also be quite diverse. It can be nuanced, it can be complex, You may want to have a conversation with your data more so than having to just figure out some logic up front, and that's what you're passing in and getting back. Pre-processing, we're getting better at it. It's becoming more efficient, but it introduces rigidity, it introduces cost, and it can even introduce some latency and signal loss. Interoperability and FHIR have definitely made this better, but there is still some challenges that are there, and for folks that are on the ground working with data with customers, I'm sure that you see those challenges day in, day out. So, to get to the recent advances, we could talk a lot about large language models. I'm going to focus today just on one of Google's models, Gemini 1.5. This model supports long context. What do we mean by that? We mean that it can support 2 hours of video content. It can support, many books all passed into one context window. And of course, in the context of this discussion, it means it can support passing an entire multimodal medical record also into that context window. We already spoke about recall, multimodality. You can also have grounding on this model, but we'll get into that a bit later. And again, latency exists. Caching does reduce latency, but it is still significantly larger latency than, say, a deterministic system at the time of querying. Okay, so we're going to talk about 3 general genres of methods. One is deterministic. You all know this pretty well. We kind of color-coded the strengths and weaknesses of this approach. Refined in, reliable out, maybe is one way to think of it. From the generative approach, this is what we're going to focus on. The strengths, instead of being later on, are up front. There's really not much cost to get this up and running. But you do sort of pay a tax later that you didn't pay up front. And that comes in the form of higher latency and cost at time of query, as well as some hallucination risk on the post-process side once you have your result. And then there's also this hybrid approach, sometimes referred to as retrieval augmented generation, but there are also other flavors of it, such as using a large language model to generate a FHIR search or SQL on FHIR logic out of a question that you may pass in, get the data back, and then do some generation on top of it. So this is really sort of a spectrum more so than just 3 approaches. And essentially the purpose of this talk is to say, hey, this thing on the right side, this generative-only approach, it's now feasible for asking questions of an entire medical record. In terms of use cases, again, we still believe the deterministic approach is the right approach for the vast majority of use cases. But moving forward, we do think that the hybrid approaches, in particular, we're pretty excited about those, as well as generative-only approaches may play a role moving forward depending on what your use case is. Okay, we're probably going to skip through these slides a bit, but I wanted to share them so that you could see in more detail kind of a framework of how data moves through the process and how it differs for a deterministic approach compared to a hybrid approach. You have more data that's able to be brought in because instead of mapping all data fully to FHIR in a RAG approach, you can map sort of the bones of your data to FHIR and then reference out to other data that may be available to you, but you don't necessarily want to map all of it fully into FHIR. And I do want to give a shout out. Raquel's going to give a talk later today on this topic. This is what our Vertex AI search for healthcare product is. So I'm excited for that talk. And again, this is the generative approach. You can see you can pass in more data on the left. There's less stuff you have to do in the middle, but you do pay your tax later. Okay, I'll also go through these fairly quickly. We all know what FHIR search is. We all know how it works. Just showing it here. Query in, you have to have formal logic, and you'll get back the right result essentially every time, and you'll get it quickly. Retrieval augmented generation, you can pass in a more natural language version of your question, and you have pretty good confidence that you'll get the right result back. And if you don't get the right result back, you will at least have the data that was retrieved that went along with that question that you can then essentially use as a way to audit or ground that response that you get back. Latency is still fairly low, and cost is still fairly low, although it is higher than a deterministic approach. And this is the generative approach, and we'll show this in more detail in a bit, but essentially, your query is now just a prompt into the same context window that you would use for anything else. You point it at the right model, and you get a response back. The difference is, again, higher latency, higher cost. But essentially, no pipeline needs to be built to have this solution. So now we're getting into the data that was used for this effort. It's worth noting that it's not so easy to find synthetic data that is sufficiently multimodal and coherent. Shout out to Cynthia and MITRE. They do amazing work. This Cynthia coherent data set was helpful in building a multimodal data set, but even that isn't actually highly multimodal. There's some data that's there, but not other data. And while it is coherent, it isn't actually as coherent as maybe we would like it to be. For example, the notes are essentially deterministically derived. So for things like benchmarking, there isn't that much, it doesn't feel real compared to using data in the wild. So for this, we pumped in a bunch of data. It ended up being around 500K of tokens, but again, this model can handle up to 2 million. There's a lot of FHIR data in there. It is worth noting FHIR was the largest sized amount of data. That's also because there's the most signal in there, because in this example, we had a lot of FHIR data. I do think it is interesting to note, and I think it's an area for future analysis, the ratio of the amount of tokens related to the amount of signal in FHIR data. It may, in fact, be fairly verbose in raw format for that ratio, and it may be an area where some pre-processing of FHIR data is quite useful. Okay, let's get into findings. We created sort of 4 use cases: search, summarization, synthesize, and we needed an S for the last one, so I called it super helpful multi-turn. But really, it's just multi-turn. So search is like essentially a needle or needles in a haystack, right? So anything where you're looking to get those needles back, but you're not really asking necessarily for much more than that. Summarization is, let's say that you want to generate an after-visit summary. So the LLM is going and looking at the record, finding the data related to that visit, and then generating that summary for you. Synthesize is a bit more. Maybe you're asking the model to have some critical thinking in there. In this example, let's say it's for a patient and whether they do or don't meet the prior auth requirements for a GLP-1 like Rosenfeld. And if so, draft the prior auth form. So again, no pipeline, no anything. We just pass it all in. And then multi-turn, as you can imagine, is chat. So that's actually quite useful for these purposes, because the more that you're able to chat with your data, the more you realize that, or at least for me, that I realize that it's actually what I always wanted to do when I'm talking to a medical record. Just putting something in, getting one response back, that's useful, but having a conversation with your data is really quite powerful. Okay, so here's search. For the sake of time, we're going to stay fairly high level, but I will, again, I know it's kind of small on here, but essentially, this is straight in the console. This is just our user interface in Google Cloud. Obviously, it's typically accessed via API, but I just wanted to show it in a slightly nicer way. This is actually hitting Gemini Pro's 1.5 version. The Pro version, we also have a Flash version, which is faster, but for this, we used Pro to see if we could have slightly more robust responses. Temperature is set at 1. We've played around with temperature a good amount, and it really depends on what your use case is, in whether you want a temperature lower than 1, whether it's 0.5 or 0. We haven't really gone above 1 for these use cases because it doesn't seem like the thing to do. So for search like this, we are searching over all of that data that we saw on that slide before, the LLM is pulling the entire thing straight into the context window, reviewing all of it, and in this case saying, hey, here's your vaccinations. In this case, it found 15 of them, which is actually the correct answer. And it pulled it from FHIR data, CCDA, V2s, as well as a PDF of the clinical note. So fairly impressive when it can return a correct result. I do want to be clear that it doesn't always return the right results. Sometimes it will only look at some of the sources as opposed to all the sources. Sometimes it will confuse, it will give the right answer, but it will give the wrong number. So it'll give you 15 immunizations and it'll say there's 12 at the top. Sometimes it will incorrectly say that an immunization is from the CCDA document when in fact it's actually from the FHIR document. So I do want to be very clear that particularly for search, actually, we've found, it can give the right answer. It usually gives the right answer, but there are plenty of pitfalls, things that there are enhancements that we can make that you'll see discussion of later, but just using it with out of the box with nothing on top of it, there is risk of hallucination. And again, something to note here, for this type of query, we are looking at around 30 seconds of latency. So this is not fast, but it is getting faster. Okay, summarization. This one is create an after visit summary. It's pulling, we gave it a date, it goes and finds the information in the record. It gives a summary in the format that we requested. Obviously, you could pass even more data into the prompt and say, here's the exact format, here's some examples of the after visit summary that I would like. All these things are possible, but this was just sort of basic out of the box, as basic a prompt as we can do. Synthesize. For this example, we're saying, hey, can you draft a prior auth form for this patient related to Ozempic? So we pass all the medical record, and then we also pass a PDF of the Ozempic prior auth form. Again, obviously, it would be better to use deterministic approaches for this. DaVinci is doing amazing work on this front for prior auth, but we wanted to show that you can do this type of thing with both a medical record as well as another document, and the LLM can handle bringing those two things together and drafting a response. Multi-turn. This example, essentially we pass in the record, and then we say, tell us about the patient related to diabetes. Can you list BMIs? And then, hey, can you evaluate whether this patient meets the criteria for diabetes or pre-diabetes using a standard of care document? So, it isn't as though you just have to pass the data in at the beginning and then you're chatting and you can't add more data. You can add more data along the way whenever it's helpful to you. And this is a video of it happening. Hopefully it works. Yeah, so you can see the user interface doesn't work that well for showing all the data, but essentially, you can pass it in. I'd already kind of loaded this one, but the multi-turn does work faster, particularly as you ask questions using caching. Okay. Oh, I might have to wait for it to finish. Oh, no. Okay. Conclusion. We're trying to make sure we have time for questions here, so. All right. So to come back to that visual that we showed before, let's focus on use cases first. Again, we think that this use case today is currently best suited for versatile proof of concepts that are professional in the loop. I think personally, I'm more excited about the lower two of this list of 4 use cases, the synthesize and multi-turn, because they are things that are a little bit harder to do with deterministic systems. It is helpful to have search on multimodal data, but RAG, the hybrid one in the middle, is probably your better bet for that. Okay, enhancements. There's a lot of things that you can do using this basic approach to make it more robust. On the pre-processing side, we do think that there are advantages to optimizing the format of the data before it's ingested. We don't have answers yet on exactly what that optimization looks like, but we do think that we can see performance improvements by doing that. And We'll get to benchmarking in a minute, but benchmarking will be a big piece of figuring out how things can be optimized. Also, deduplication of data. There may be some advantages to, if you're pulling in lots of diverse records, there could be a lot of duplication across those records, and there could be advantages to having sort of a pre-processing stage to eliminate that duplication. On the prompting front, prompt tuning, which we talked about a bit, adding examples, certainly important. Prompt templates, as well as caching, we do think can significantly improve these sort of preliminary results. Post-processing, there's a lot that you can do here, whether it's an output parser or an output validator, finding scores that might indicate hallucination in the results, running adversarial models, as well as ensemble methods. You may, in fact, do a range of hybrid and generative approaches. Some of those hybrid approaches may actually use deterministic approaches under the hood. And then grounding is also quite important. Okay, next steps. Formalizing a reference architecture for this. It's pretty basic, right? But as we add in some of these enhancements, there is a little bit of a pipeline built, so that'll be useful to show. Secondly, benchmarking. We think benchmarking is going to be really important here. We are talking to our research team about the best ways to do that. But again, we are somewhat limited by the synthetic data that's available to benchmark off of, because it isn't quite what we would want it to be to show the power of this approach. And then lastly, sharing lessons learned from POCs as we work through them. Okay, this is the last slide on implications on FHIR. I'll let Vivian speak to this one, and then we'll get to Q&A.
Yeah, so I am what I will refer to as Will's insurance policy right now, because there's probably at least one person in this room that's like, wow, Google just spent their entire sponsor session at a FHIR developer conference talking about how FHIR maybe is not as important as we thought it was, or something like that. And I'm here to say that's not entirely true. A lot of what we're realizing, and none of this isn't just because like my job hinges on FHIR being important. It's actually because one, as we all know, FHIR as an exchange mechanism will always be cheapest and fastest as a transfer API and as an exchange format. And so, a lot of what we're talking about here, the ways that we think about FHIR as an exchange mechanism really don't change and are really not impacted by that. But I think the second thing, and a lot of what I at least have dealt with in my role, is the implementation and upfront cost of getting people to use FHIR. So people who are coming outside our legacy database users, or people who are not familiar with FHIR, it is very difficult for them to learn FHIR, to implement FHIR, to start building applications on FHIR. And I have spent the last bit of my career hand-holding many enterprise organizations through where a patient first name actually goes in the standard. And probably a lot of people actually can resonate with that. And so I think one of the main takeaways, at least for myself, was we need to start thinking about how we can actually gain a lot of insights from data that's coming from multiple different sources, and maybe not having to perfectly map all of that. So what I start telling people is, how much can you throw into a binary resource and have some other processing mechanism make sense of it? How much of this data beyond, let's say, US Core or whatever implementation guide is not needed for exchange, but you don't want to lose that information, PDFs, et cetera? Can maybe there's just information in raw text that you don't want to parse yet. Throw it in an extension, throw it somewhere. And there's a lot of mechanisms that are coming about that can make this actually so much more meaningful. And we can start finding insights that we haven't been able to from data without making all of the non-people sitting in this room learn and have a huge implementation cost, because we're having them map everything to the exact specific field that the standard dictates. And so, happy to take questions, happy to talk about this, but I think really this isn't in any way saying, we are still very committed to FHIR, and we're still building a lot of products on FHIR, but I think this is an interesting discussion for us to think about how we can start to be our own multimodal kind of community.
All right, thank you. Question time.
Wonderful talk. Thank you. In the multi-turn approach, oh, sorry, I'm here. In the multi-turn approach, is it possible to, I come from the payer side, so health risk assessments is a very common thing. Is it possible to upload a questionnaire in a PDF form and ask the LLM to populate the answers, assuming that the audio files, the recording with whatever the care manager spoke with the member, and all the health history is uploaded?
Yes. The answer to most of these questions is yes, it's possible. The question then becomes, how well does it work? In what ways, as you move from a POC to a pilot to production, do you want to add in additional steps either in the pre or the post side to make sure that you're putting the right guardrails around it, that you're mitigating hallucination, that you're doing what you need to do to have the process work as best it can? I think one analogy maybe to make is deterministic approaches with FHIR are kind of like the mass transit way to do things. It's reliable, it's lower cost, it works well, it's efficient. This approach is kind of like Uber with a dump truck, right? You can take everything, you can put it in the dump truck from where you have it, and you can take it wherever you want to go, and it'll make something, but you also need to be careful about what it makes and the validity and accuracy of that thing that it's building.
How do you go about benchmarking the quality of output? What parameters do you measure on? And also, what is your strategy for even choosing those parameters?
Yeah, it's a great question. For the healthcare domain and for this sort of multimodal asking questions of longitudinal comprehensive medical records, like I said before, I don't think that we have quite robust enough data to be pumping into these models to then benchmark on. I think the best that I've seen for this type of thing is probably Cynthia coherent data, but even that, I think, maybe leaves some stuff to be desired, and if anyone from MITRE is here, I'd love to talk to you about how to sort of add to the latest versions of Cynthia to make it even better for benchmarking. But that's probably the place to start. Our research team has done benchmarking off of mimic data as well, and that was specifically on sort of the needle in a haystack search style approach, but similar benchmarking could be done on these other types of use cases. And in terms of scores, there are scores like rogue scores. There's different things you can do to kind of approximate potential of hallucination, but I think more is probably needed in this space as well.
Hi. So my question is about when asking questions on a large data set, as models keep getting better and better, we might have needles in a haystack till like a long context length. But what's your opinion on instead converting this first to, like, let's say, a database, and then have the models generate SQL queries that are explainable as opposed to just feeding it raw text?
Yes, we are very excited about that approach, and I personally believe in that approach as a very valid way to go. This is, again, the purpose of this talk is to show there is this thing way over on the far side of the spectrum, and it is possible today. It isn't to say that it should be the way that folks should proceed today. So I do think that this hybrid approach of using an LLM to generate a deterministic set of logic, retrieving that data, and then maybe generating on top of it is a very valid approach. And that database can be FHIR, probably should be FHIR, and you can reference out to other modes of data from there. And that's what we're actually going to have a talk on later is that style of doing things.
How are you dealing with the problem that the most models are trained on like natural language and not necessarily on like the medical text and aspect? did you train your model like specifically with the synthetic data, or was it like based on like the natural model previously?
Yep, so what we showed today, that is the out-of-the-box Gemini 1.5 Pro model. Google also does have a MedLM model that is more specifically trained in the medical domain. And actually, the Vertex AI search for healthcare product, you can pick which LLM you want to use, whether it's the base Gemini model or the MedLM model. What we were showing today, because MedLM doesn't support context windows today of 2 million, this approach is not feasible with MedLM, but in the future, that may be something that's possible and something certainly worth testing out. It's obviously a very evolving landscape, so this stuff changes all the time.
And a lot of the future direction is actually helping organizations use their own data to uptrain and create their own proprietary example of these models so that they can have very tailored and much more accurate results from models based on how they structure their data, what data they're dealing with, et cetera.
Great. That's all the time we have. Thank you very much, Vivian and Will.
Thank you.
I want to skip, you actually skip 3